Good morning. Today I'm going to present my Physics 2 Lab 2, which is the part 2 of charge tapes. The purpose of this lab is to exemplify the physics behind Coulomb's law and electric fields and how these can make charged objects attract or repel. This is Coulomb's law and this is the electric field's law, and this is how charges attract or repel. The principles in actions are Coulomb's law, which describes how an object with charge reacts with an electric field and produces attraction or repulsion. As you can see in this picture, the upper tape was repelled from the lower tape, making it float. The electric fields describe how charged objects create electric fields. So this is the experiment, which the object selected to analyze was a tape. The position of the center of the mass of the tape was tracked, and the distance lifted was measured with a ruler. The origin was set to the position of the lower tape. Here is the video of how we put the lower tape and made the upper tape float by repelling it. So here the system and the surroundings. The systems is the upper tape and the surroundings are the lower tape and earth. As you can see, this is for a single point charge where the electric force is pointing upward and the gravitational force is pointing downwards, and here is the tape composed of many parts, and here's the lower tape. The description of the computational model. This computational model was different from last lab because the tapes were not treated as point charges. The tapes were divided into 30 molecules of equal size that received the exerted force by the lower tape. The electric force and gravitational force were calculated by the program. Here's a video of the code. As you can see, this was the function to calculate the electric field. The other one was to create the line of molecules. Now here we created the top and bottom tape, and this calculated the force for each part in the top tape by the bottom tape. As you can see, here are all the forces on each part of the upper tape by the lower tape. The results were that the magnitude of the electric field was 3.3 times 10 to the negative 4, and the magnitude of the gravitational force was 2.45 times 10 to the negative 3. Here is the photo of the computational model. Possible sources of error. In the division of the tapes in 30 pieces, the electric force for each one could have been calculated wrong, and the summation of all forces could also have been calculated wrong. Assumptions. Ignored air resistance on a moving object, treated the long tape as if it were composed of 30 equally charged parts, and each part was treated as a point charge, and assumed that each U-tape we made had about the same amount of charge, evenly distributed along the length of the tape. What if we had modeled each of the tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to evaluate the value you got with your line charge model. The previous value of the electric force was 3.13 times 10 to the 5, and the value for this model was 3.3 times 10 to the negative 4. Both values of the gravitational force were 2.45 times 10 to the negative 3. Why do these estimates differ? Which value is more likely to be closer to a real value, and why? These estimates differ in the way they are calculated. The electric force differs when treated as a point charge because the charge is not completely distributed across the surface, but concentrated at just a single point. The value that is likely to be closer to a real value is the line charge model, because it simulates better how the charges work in real life. Here's the link to my simulation. Thank you.